In our lesson today, we're going to do a nice review of proportional relationships, and we're going to start by looking at graphs, okay? From a graph, we said before that a proportional relationship looks like a straight line that's passing through the origin. And so if we look at our first graph here, it says it's the distance run by a cheetah, okay? We can see the time in seconds along the x-axis, the distance in feet along the y-axis, and our graph here definitely shows a straight line that is passing through the origin right here at 0, 0. So this graph represents a proportional relationship. And the first thing that they want us to do is to figure out the constant of proportionality, k. Remember that to find k, you always set up the ratio as y over x, the dependent variable over the independent variable. And for the value of k, the unit rate, the denominator, always has to be equal to 1. So what we're going to do is find 1 on the x-axis. So let's find our value of 1 on the x-axis. So we're looking down here. Here's where 1 on the x-axis is. You go up until you hit the line, and then you come over to the y-axis, and we see here that that gives us a value of 90. So in this example, k equals 90 over 1, or just 90. This means that the cheetah can go 90 feet in 1 second. 90 feet in 1 second. All right, 90 times 1 is 90. Okay, 180 feet in 2 seconds, and we get that by doing 90 times 2. 90 times 2 is 180. The cheetah can go 270 feet in 3 seconds, and we do that by doing 90 times 3. 90 times 3 is 270. So for this example, remember the equations are always set up the same way, y equals k times x. And in this example, k was equal to 90. So y equals 90 times x. The distance equals 90 times the number of seconds. Similarly, in our example underneath, we can see that this is the number of boxes packaged. We have the time in minutes along the x-axis, and we have the number of boxes along the y-axis. And once again, our graph is showing a straight line, and it's passing through our origin, so we know that this is a proportional relationship. And once again, we're going to look for that constant of proportionality, k. K again equals y over x. And for the unit rate, the denominator needs to be a 1. So once again, we're looking for 1 on the x-axis. So here's our x-axis. Here's 0. Here's 2. So this must be where 1 is located. Go up until you hit the line, and we come over. And notice there's no number there, but this point is halfway between 0 and 120. Which would mean it's equal to 60. So we would put a 60 right up here. That means that the value of k is 60 over 1, or just 60. And it means that they can package 60 boxes per minute in 1 minute. That means that they can package 120 boxes in 2 minutes, and they get that by taking k, which is 60, and multiplying it times 2. 60 times 2 is 120. They can package 240 boxes in 4 minutes. And again, you take k, which is 60, and multiply it by 4. 60 times 4 is 240. 360 boxes equals 60 times 6 minutes. They package 360 boxes in 6 minutes. So for this example, we're going to have y equals 60 times x. Again, that value of k, y equals kx. All right, y equals 60 times x. Remember that there is a proportional relationship between x and y, that y is a constant multiple of x. That constant multiple is your constant of proportionality, k. So y is your dependent variable, x is your independent variable, and your equation will always be y equals k times x. Put a star next to that. For every proportional relationship, the equation will be in the form of y equals k times x. In our next example, we want to know if this equation right here, y equals 2x plus 1, is that the equation of a proportional relationship? And in order to figure that out, we're going to come up with values that work for this equation. So x, remember, is your independent variable, so we can choose any values that we want for x. And we're going to use the values 0, 1, 2, and 3. The value of y depends on the value of x. The way that you get the value of y is by substituting the x value into this equation. So for this example, we're going to have to do 2 times 0 plus 1. Following the order of operations, we would have to multiply first. 2 times 0 is 0. Add 1, that gives us a value of 1. So when x is 0, y equals 1. Okay, what if x equals 1? Well, again, just substitute 1 into this equation. 2 times 1 plus 1. 2 times 1 is 2. 2 plus 1 equals 3. All right, so when x is 1, y is 3. If x is 2, again, substitute that in. 2 times 2 plus 1. 2 times 2 is 4. 4 plus 1 is 5. So when x is 2, y is 5. And then finally, when x is 3, we're going to do 2 times 3 plus 1. 2 times 3 is 6. 6 plus 1 makes 7. When x is 3, y is 7. We're now going to take this data and we're going to plot it on this graph here, but first we have to make our ordered pairs, which were x comma y. So our first point, I should say, is going to be when x is 0, y is 1, 0 comma 1. Our next point is going to be when x is 1, y is 3, 1 comma 3. Followed by 2 comma 5, x is 2, y is 5. And then finally 3 comma 7, x is 3, y is 7. Let's plot these 4 points on this graph over here. So we'll start with 0 comma 1. X-axis is 0. The value of y is 1. So I'm going to go up 1 spot from the origin and put a dot. Then I'm going to plot 1 comma 3. So from the origin, right once, up 3 times. Then 2 comma 5 from the origin, 2 to the right and up 5 right here. And finally 3 comma 7 from the origin, 3 right, up 7. There's 6. So 7 is actually going to take us a little bit off of the graph right there. And now use a straight edge in order to connect all of your points. And it would look something like this. Don't forget your arrow at the end. So this is what the graph of this equation, y equals 2x plus 1, looks like. We want to know if this is a proportional relationship. Remember, for the graph to be a proportional relationship, it needs to be a straight line that passes through the origin. This is definitely a straight line, no arguments there, but it is not starting at the origin. The origin is down here, all right? This line starts at this point, which is at 0 comma 1. So this is not a proportional relationship because the straight line does not pass through the origin. The line passes through the point 0 comma 1, all right? I also knew that this relationship would be non-proportional because this equation is not set up in this form. Remember, we said before that if the equation says y equals k times x, this represents a proportional relationship. This shows y equals 2 times x, but then it has an extra plus 1 at the end. This part of the equation right here is what makes this non-proportional. If it only said y equals 2x, you would have a proportional relationship. But since it said 2x plus 1, notice that the line started at 0 comma 1. This plus 1 moves it from the origin up 1 unit, which is why it starts at 0 comma 1. So this is a non-proportional relationship because this equation is not in the form of y equals k times x. So based off of the last example, we have to determine if the equation represents a proportional or a non-proportional relationship. Remember, for a proportional equation, it has to look like y equals k times x. So in this example, Does the equation y equals 11x show a proportional relationship between x and y? Well, if we line everything up, y equals k times x, this equation lines up, it matches up perfectly. So this equation does represent a proportional relationship. So if we read through our choices, E and F both say no, that this isn't proportional, so I know they're wrong. G and H both say yes. Let's read these carefully. G says yes, the graph is a straight line that passes through the origin. H says yes, the graph is a straight line, but it doesn't pass through the origin. Well, if it doesn't pass through the origin, that would make it not proportional, so that doesn't work. G is the correct answer. This would be the equation of a line that passes through the origin. Part B says, if yes, what is the constant of proportionality? Well, that's the value of k. K equals, well, all you have to do is line it up right here. We can see that k has a value of 11. So this is definitely an equation of a proportional relationship. Question 2a. Does the equation y equals 3x plus 5 represent a proportional relationship? Well, again, it has to look like y equals k times x. And in this example, y equals k times x, but then it's got a plus 5 at the end. And if we remember from our example before, when we had a plus 1 at the end, this plus 1 right here moved the line up 1 unit from the origin, and this made it non-proportional. So in this example, where it has a plus 5, this is going to move it away from the origin. It's going to move it up 5 units. Okay, so this is not going to be a proportional relationship. So G and H both say yes, it will be. Those are gone. So it's got to be either E or it's got to be F. E says the equation won't be a straight line, but F says the graph will not pass through the origin. And that is the true statement here. This graph will not pass through the origin because of this plus 5 right here. Instead of starting at the origin 0, 0, this is going to start at, starts at the point 0, 5. Because we've added 5 here at the end, we're going to move up 5 units from the origin. All right, if yes, what's the value of k, the constant of proportionality? Well, this was non-proportional, so k doesn't exist, and again, we write n/a. In the next set of examples, we're going to create equations from tables. Remember that from a table of values, you have to figure out the value of k, the constant of proportionality. All right, the constant of proportionality k was always found by doing k equals y over x, y over x. So if we look at our table here, we see our headings, we have x and y. What we need to do is come up with the ratios of y over x. So in our first set, when y is 10, x is 5. So it's going to be 10 over 5. Then with the second one, when y is 6, x is 3, 6 over 3. And then with the next one, y is 2, x is 1. And if you look at the last set, it's 0 and 0. So there's technically no data here. So we're not going to create a ratio for that. So we're going to ignore that last step. We're just going to look at these 3 here. We need to simplify these down to a unit rate. So that means your denominator needs to be a 1 in each case. And if it's 10 over 5, 5 divided by 5 is 1, 10 divided by 5 is 2. If it's 6 over 3, 3 divided by 3 is 1, 6 divided by 3 is 2. And in our last one, 1 was already the denominator, so this is going to stay 2 over 1. All 3 unit rates were 2 over 1. So the constant of proportionality is 2 over 1, or just 2. And remember, for the equation is set up as y equals k times x. Well, we just did k, the constant of proportionality here, and got a value of 2. So the equation is going to say y equals 2 times x, or y just equals 2x. All right, same thing for the next table. We have our x and our y. The ratios are y over x. Once again, if it's 0, 0, there's no data, so we're not going to set up a ratio for that example. All right, y is 5, x is 1, so it's 5 over 1, which is already a unit rate. Y is 10, x is 2, 10 over 2. Make it a unit rate. 2 divided by 2 is 1. 10 divided by 2 is 5. Last one, y is 15 and x is 3. 15 over 3. Make it a unit rate. 3 divided by 3 is 1. 15 divided by 3 is 5. All three unit rates are the same, so this is a proportional relationship. Your constant of proportionality, k, equals 5 over 1, or just 5. And for your equation, y equals kx, just replace k with 5 in this case, y equals 5x. In the next set of problems, we're going to show how we can find out equations from word problems. We're going to match the situation to the correct equation. Remember that you must find the constant of proportionality k in order to be able to pick out the correct equation. So the three equations that we have are y equals 5x, y equals 60x, and y equals 10x. All three of them represent proportional relationships because they're all in the form of y equals k times x. So let's take a look at example number 5, and let's see if we can pick out which equation represents this example. A certain vegetable dip contains 60 calories per serving. What equation represents the number of calories, which is y, okay, in x servings of dip? So remember, in this, k is always equal to y over x. And in this example, that's your calories over x was your servings. Okay, well, they told us right here that it's 60 calories per serving. So that means it's 60 calories in one serving. And this right here is already a unit rate. So k equals 60 over 1, or just 60. Since that's the value of k, we come up to our three equations. The one that has a value of k equals 60 is this equation right here. So the equation would be y equals 60x. In the next example, it says at a telethon, a volunteer can take 60 calls in 6 hours. What equation represents the number of calls, which is y, number of calls is y, a volunteer can take in x hours? So to find k, the constant of proportionality, it's y over x. Y is the number of calls. X is the number of hours, calls per hour. Well, they told us that they can take 60 calls in 6 hours. 60 calls in 6 hours. If you make this a unit rate, 6 divided by 6 is 1. 60 divided by 6 is 10. So k equals 10 over 1. Or just 10. Coming back up to our equations, it must be this equation here, y equals 10 times x. The value of k here is 10. Finally, in example number 7, a machine can make 60 keys in 12 minutes. Write an equation that finds the number of keys y that the machine can make in x minutes. So k equals y over x. In this case, that's the number of keys in the number of minutes. They told us here that the machine makes 60 keys in 12 minutes, and we need a unit rate to figure out how many keys can be made in 1 minute. Well, 12 divided by 12 is 1. 60 divided by 12 is 5. So k in this case is 12 over 1, or just 12. So looking back at what we had, excuse me, not 12 over 1 or 12, I made a mistake there. K equals 5 over 1, or 5. So looking back at our equations, it must be the first equation here because the value of k is 5. Y equals 5x. So if they give you a word problem, figure out the value of k, the constant of proportionality, and that will help you come up with your equation.